Hi, everyone. Welcome back for 2.3. So in 2.1, we started talking about the coordinate plane. 2.2, we talked about any graph, how we can get any graph. And now we're going to look at the very specific study of just lines. So the entire section is just about lines. So first thing we're going to talk about is slope. So linear equations, right? We looked at linear equations in early chapter 1. And linear equations result in lines for graphs. That's not really surprising, right? Linear lines, right? So the first thing we need for a linear equation is the slope. Now, the slope of a line represents the steepness of the line. You know, how fast does it grow or how fast does it decline? How slowly does it decline and so on. So one way that a lot of people remember this is rise over run, or in other words, the change in y divided by the change in x. So to find slope, we use the letter m, and m is given as y2 minus y1 over x2 minus x1. So same way as we found midpoint, same way as we found distance, same way as we have found a lot of different things with x1, y1, x2, y2, same thing here. So we're going to subtract the y values, divide by, subtract the x values. So rise, how much does the y change? How much do we go up and down over the course of some interval, divided by how much we changed in terms of x, how much we ran, so to speak. So if your slope is positive, your line trends upward. So positive slope goes up. If m is negative, though, your line trends downward. So positive slope, positive m is kind of like something is growing, whereas negative slope is like something is decreasing. If you have m equals 0, your line is horizontal. So if that's the case, it means the line is running, but it's not rising. So for example, if it doesn't rise, if it's horizontal, right? Horizontal, the y value doesn't change. Well, 0 divided by anything is just going to be 0. So m equals 0 are horizontal lines. Vertical lines, on the other hand, similar, but they have undefined slope. Well, vertical lines, they rise, but they don't run. Well, so if it's rising but not running, y is changing and x is not. So in that case, anything divided by 0, undefined. So in the very specific case of vertical lines, they have undefined slope, whereas horizontal is 0 slope. Very different. So let's do some practice of just finding slope. So we have 1, -1, and 3, 3. Just like we've done in the past, this can be x1, y1. This can be x2, y2. So our slope is y2 minus y1 over x2 minus x1. So we're going to take the y values, subtract them, 3 minus -1 over 3 minus 1, the x values. 3 minus -1 is just 3 plus 1. Well, 3 plus 1 is 4. 3 minus 1 is 2. So our slope is 2. So for every 1 unit that we run, we go up 2 units. Or for every 2 units that we run, we rise 4 units, and so on. Okay, let's do another one. -7, 5 and 6, -3. Well, we know what the slope equation is, so we don't need to, keep remembering it each time. But here we go. Here's the slope equation. Same thing. Let's subtract the y's. -3 minus 5 over 6 minus -7. 6 minus -7 is addition, so 6 minus -7 is plus. $3 in debt, spend $5 more, you're $8 in debt. So 6 plus 7 is 13, or just -8/13. So both of these would be correct. Okay. -2, -3, and 5, 4, same thing. y2 minus y1 over x2 minus x1. Both cases, minus is plus. Well, 1. That means for every unit that we rise, we also run 1 unit. It goes up 1, right 1, up 1, right 1, up 1, right 1, and so on. But just like a lot of the other things we've talked about so far in this chapter, order doesn't matter. So using the exact same points, if we instead want to use, 1, -1 as x2, y2 for some reason, right? Maybe you just prefer going that way. And then this was x1, y1. Well, guess what? -1 minus 3, -4, 1 minus 3, -2. -4 divided by -2 is +2. Exact same answer we got in the last slide. Okay, same thing. -7, 5, and 6, -3. Let's call this x2, y2, and this one x1, y1. All right. Well, okay. So 5 minus negative 3 is plus. $7 in debt, spend 6 more dollars, negative 13. 8 over negative 13 is the same as negative 8/13. Just like the last one, right? Numerator's negative or denominator's negative. We can just write that negative on the outside. Last but not least, let's do the same thing with these last 2 points and see that we get the exact same thing. You're $3 in debt. You spend 4 more dollars. You are $7 in debt. Or if you have $2 in debt and you spend 5, you're still $7 in debt. Negative 7 divided by negative 7. Anything divided by itself is 1. Okay. So that's slope. And what we want to do is write equations of lines. And we have 2 ways we do that. We have 2 ways. One is called point slope form, and the other is called slope intercept form. I personally really like slope intercept form, but a lot of people across the world don't mind slope intercept. So I'm going to be very centric to slope intercept, but don't think that point slope is necessarily bad. It's really just a preference in the way I teach. So here's the slope equation. And what if we multiply both sides by x2 minus x1? Just multiply both sides by the denominator. Well, here, this obviously cancels out. That's the whole point. And if we just rearrange terms and relabel some things, this is what is called point slope form. It's called point slope form because you have the slope m, and you would plug in any point on the line, x1 and y1. So for that reason, since you are plugging in a point and a slope, it's called point slope form. So we need 2 points to find the slope, but we only need to include one of those 2 points when we're doing point slope form. Now, it doesn't matter which one we're given. So, we need 2 points to find the slope. That we can't negotiate on. But of those 2 points, when we go to plug it into point slope form, we have a choice of using either point. So let's do just that. Let's say we have these 2 points, negative 3, 1 and 2, 11. I want to find point slope form, and then I want to solve for y. Okay, well, we start with the slope always. Let's subtract the y values divided by subtract the x values. 10 over 5, that's 2. Okay, well, point slope form is this equation right here. And what we're going to do is plug in 1 point and plug in the slope. So for this one, let's plug in negative 3, 1 for x1 and y1, and we're going to plug in 2 for m. So we get y minus y1, which is just 1, equals 2x minus negative 3. Okay, well, we can do one step of simplification. X minus negative 3 is x plus 3. And this is formally point slope form. So a lot of people in math don't mind this notation right here to write lines. But for me, let's say we want to solve for y. Okay, well, we can distribute 2, and then we can add 1 to both sides, and we get y equals 2x plus 7. Okay, I think it's a little cleaner this way. We have a name for that thing. Well, I already said it before, but we'll give it just another second until we get there. But I just also want to take the time to show you that it doesn't matter which point we use. I told you can use either point and you should get the exact same answer. So let's do the exact same thing, but with 211 instead. So slope is still 2, right? Same 2 points, but we're going to plug in 2 for x1 and 11 for y1 this time. All right, we still distribute 2. This time we're going to add 11 to both sides to solve for y. You're $4 in debt, and somebody sends you $11. You now have $7 again. So point slope form, they are really the exact same line when you solve for y. Now, this solved version for point slope, right? Point slope is this version right here, or the one that we had on the previous slide. But this solved for version, this kind of cleaner version, is called slope intercept form. Because what we have is the slope m, okay, surprise, surprise. And what so happens to be the case is that b is the y-intercept. Think about that. Y-intercept is when we set x equal to 0. So if x is 0, well, m times 0 is just 0, and then 0 plus b is just b. So m is your slope, b is your y-intercept, hence slope-intercept form. Okay, so let's do some practice of finding slope-intercept form. So let's do 5, 0, and 0, 8. Let's find the line between them. I have an asterisk here just because when we get to that step, I'm going to plug in 5, 0. On the next slide, I'll show you plugging in 0, 8 and how it's the exact same thing. All right, find slope first, subtract the y values, subtract the x values. Also, more so now than every other thing that we've kind of looked at, it's okay to change the order in which one is x1 and y1 and x2, y2, but just be very careful that when you do that, you stay consistent. So for example, if you're calling this x2, y2, make sure that you do this y minus this y over this x minus this x. Don't magically flop and say like this is x1, y2, and plug it in that way. That's not going to be good. So just be careful of that. Okay, so we have our slope. Here's slope-intercept form. And what we're going to do, similar to point slope form, just with a different equation, we're going to plug in slope m, but instead of plugging some point into x1, y1, we're just going to plug that point into x and y. Writing equations, you've already seen that every equation has a y and has an x, but b would be new, so we need to solve for b. Okay, so y is going to be 0, m is going to be negative 8/5, and x is going to be 5. We'll start by plugging in the slope, and now I'll plug in that term. All right, 5 cancels out. We're going to add 8 to both sides, and we get b equals 8. Now, that's not the end of the question. We want to write the formal equation. The formal equation says y equals negative 8/5 x plus 8. And that is very formally slope-intercept form. And now you see that because we have the slope negative 8/5 and we have the y-intercept 8. Oh, it actually happens to be right there. But just for the purpose of showing you, that's how we would get it. Well, let's do the exact same thing, but this time we're going to use 0, 8, just to show you that it doesn't matter what point we plug in. So now let's plug in 0 for x and 8 for y. All right, well, negative 8/5 times 0 is just 0. Oh, look at that. B is 8. So if you do this correctly, it doesn't matter what point you plug in, you should get the exact same answer for point slope, for slope-intercept form. Okay, let's do another example of that. 11/20 and 8/14. Let's start by finding the slope. At this point, we're pros of doing this. Let's subtract the y values divided by subtract the x values. Subtract, and negative 6 divided by negative 3 is positive 2. Okay, so in y equals mx plus b, m is 2. And now we want to solve for b. I believe I'm going to plug in 11/20 for x and y. Yeah, there we go. 2 times 11 is 22. Subtract 22 on both sides, we get that b is negative 2. So the answer to slope-intercept form is y equals 2x minus 2, or plus negative 2, but also, plus negative 2. It's a lot easier to just write negative 2. And again, for practice, try doing the same thing with 8/14. In this step right here, you'll see you get the exact same answer. Alrighty, let's do another set. Negative 5, 1, and 2, 7. Subtract the y values over subtract the x values. 2 minus negative 5 is 2 plus 5, so we get 6/5. 6/7, sorry. Okay, well, y equals mx plus b. M is 6/7, and we're going to plug in an x and a y. I don't remember which one I use. We're going to use the second point here. Alrighty, so plug in 2 for x, 7 for y. 6/7 times 2 is 12/7. We're going to subtract 12/7 on both sides. I'm going to trust you can subtract fractions. So slope-intercept form is y equals 6/7 x plus b. B is 37/7. Okay, so now that we have slope-intercept form, we actually can now graph lines in a slightly easier way. So the easiest way to graph is to find the x and y intercepts of whatever your line is and connect them infinitely. That's the easiest way to graph lines. So let's graph y equals 4x plus 12. All right, well, let's find the y-intercept. To find the y-intercept, we set x equal to 0, So y equals 4 times 0 plus 12. Y is just 12, right? 4 times 0 is 0. 0 plus 12 is 12. So the y-intercept is 0, comma 12. X-intercepts, we're going to set y equal to 0. Well, 0 equals 4x plus 12. Let's subtract 12 on both sides. Let's divide both sides by 4. So the x-intercept is negative 3, 0. Okay, we're going to graph these 2 points, draw a line between them, and connect them infinitely. Easiest way to graph. So there's a little bit of theory in there as to the fact that linear equations are degree 1, and and that we needed 2 points to graph it. Now we'll come back to in chapter 3. But for now, it's good practice. Alrighty, 12x plus 6y equals 12. Well, first things first, let's get this into slope-intercept form. In general, it's a lot easier to deal with slope-intercept form, and it's a lot cleaner looking. This is technically called standard form, but, to each their own. Okay, so to solve for y, right, slope-intercept form has y all by itself. Let's divide everything by 6. Just kidding. Okay, let's start by dividing everything by 6. So 12x divided by 6 is 2x. 6y divided by 6 is y. 12 divided by 6 is 2. And then let's just subtract 2x on both sides. Alrighty, well, y-intercept, we're going to set x equal to 0. Well, pretty clear to see that y is just 2. Negative 2 times 0 is 0, so 0 plus 2 is 2. Y-intercept is 0, 2. X-intercept, we're going to set y equal to 0. So we're going to subtract 2 on both sides. We'll divide both sides by 2, negative 2, excuse me. So our x-intercept is just 1, 0. So we're going to graph those 2 points and connect them infinitely. Not bad. But we actually didn't need to do that. It was nice to get it into slope-intercept form, but nothing about this said we needed to put it in slope-intercept form. All we care is graphing the thing. Well, if we only just want to graph it and we don't care about what the actual line is, why don't we just go for finding the intercepts right away? Y-intercept, set x equal to 0. So 12 times 0 is 0. Divide by 6. Oh, we get 0, 2 again. And same thing for x-intercept, set y to 0. 6 times 0 is 0. Divide both sides by 12. We get x equals 1 again. So, kind of keep an eye out for what the question's asking. If somebody's not asking to get the equation of a line, maybe you don't need to. So just something to keep in mind. All right, one more example of this. 3x minus 4y equals 12. Y-intercept, let's set x equal to 0. So 3 times 0 minus 4y is 12. Well, 3 times 0 is 0. Negative 4y equals 12. Divide both sides by negative 4. So our y-intercept is 0, comma, negative 3. X-intercept, let's set y equal to 0. All right, well, 4 times 0 is 0. Divide both sides by 3. We get 4, 0. And there we go. Okay. So that's slope-intercept form. That's how we formally graph lines. I think it's a nice, easy way of thinking about it. But let's just look at some other weird lines, because why not? Alrighty, horizontal lines. They all have a constant y value. So their form, how you would write a horizontal line, is just y equals k. If you want to think about this in terms of slope-intercept form, think about the fact that slope-intercept form, y equals mx plus b, but we said in the very beginning that horizontal lines have 0 slope. So it'd be y equals 0x plus b. But 0x would just be 0. So you would just get y equals b. In that case, instead of using b, we just use k. Vertical lines have a constant x value. So similarly, this would be x equals h, where h and k in both cases are just real numbers. So for example, we have y equals 2 and x equals 4. Very, very, very exciting. So, but more interestingly, parallel and perpendicular lines. So parallel lines run side by side each other. Imagine you and your friend are running in the park and you are both running side by side each other. You are parallel to each other. So they never meet and they have the same slope, right? Maybe you and your friend aren't necessarily running at the same pace, but you are in the same direction, just the goal is to make sure you guys never meet or crash into each other. So parallel lines don't meet, but they have the same slope. So for a line with slope m, a line parallel to it, this m parallel notation right here, well, the parallel slope to any line would be just m. Okay, now you're kind of wondering what does that mean? M parallel equals m. It just means that the parallel slope is the same as the original. Now, a line perpendicular to another line creates a right angle when it meets. So for example, if you're running in this direction, a perpendicular line runs in this direction. You kind of create like an X or a cross, and you would create a right angle where they meet. So it's a little harder to see. It'll make a lot more sense when you see it graphed, but in that case, m perpendicular, that slope is -1 over m. A good way of remembering that is flip the slope, make it negative. Not that that's easier to remember, but I think it's a little bit easier to remember this right here. Perpendicular slope, flip it, make it negative. Okay, so let's find the equations of a line parallel and perpendicular to y equals 2/3 x plus 2, each of which will pass through 2, 8. Okay, well, here we have y equals mx plus b. The parallel line slope, okay, well here, slope is 2/3. Now, the line parallel to a slope with 2/3 is also 2/3. So m is 2/3 in our question. Any parallel line will also have 2/3 slope. Perpendicular slope is going to be -1 over m, or in other words, take your slope, flip it, and make it negative. So instead of 2/3, flip it to 3/2 and make it negative. Well, now this question is just like any other question that we've dealt with in the past. Here, we have a slope, we have a point. All we're going to do, y equals mx plus b. We have m is 2/3, x and y come from 2 and 8. All right, 2/3 times 2 is 4/3. Subtract 4/3 on both sides. We get, fraction, subtraction. So b is 20/3. So y equals mx plus b. M is 2/3. B is 20/3. So the line that is parallel to y equals 2/3 x plus 2 that passes through 2, 8 is this line right here. Okay, and there you go. They literally run parallel to each other, and they will never meet. That's the whole point of being parallel. Okay, well, likewise, doing this with perpendicular lines, this is the slope we want to work with. So plug in m, x, and y. Well, a little bit nicer here. 2 divided by 2 is just 1. Add 3 to both sides, we get 11. So y equals m, x plus b. And there we go. This is what a perpendicular line would look like. They cross, they make a right angle right here. A little bit easier to visualize. Okay, let's do another example of this, but let's find the equations of any parallel line and any perpendicular line when the original line is 5x plus 1. Okay, well, m is 5 here, right? Y equals mx plus b. So that means the parallel slope is just itself, and the perpendicular slope would be -1 over that slope, -1/5. Alrighty, so we have our parallel slope. We don't have a point this time. I'm just saying do any point. Well, the original equation's y-intercept is 0, 1. Well, why don't we just use 0, -4? I don't know, totally arbitrary. Well, y equals mx plus b. Plug in m, x, and y. So b is just -4. Y equals 5x minus 4. That's it. You have the slope. We found some other random y-intercept. And there we go. Not so bad. Alrighty, one more example of this. Perpendicular slope is -1/5. Original y-intercept is 0, 1. Let's use 0, -1. Why not? Let's be weird. Alrighty, y equals mx plus b. M, -1/5. X is 0. Y is -1. Oh, actually, that wasn't a bad choice because that's just going to go away. So y equals mx plus b. Y equals -1/5. X minus 1. There we go. Very, very exciting. And that's the end of 2.3. So 2.1, 2, and 3 kind of set up this very nice, like, what graphs are type of deal. But what we're going to do for the entire rest of the section is rest of the chapter is introduce functions. So functions are kind of like the study of algebra, right? We need functions to describe a lot of the things that we're going to be doing. And that's going to carry us all through the rest of the chapter and all through chapter 3. So I will see you in 2.4. Bye.
Hi everyone, thank you so much for watching. I hope this lecture helped and that you learned something. Just wanted to give the brief disclaimer that this lecture for this section is based on and adapted from the section in College Algebra and Trigonometry, the 4th edition by J.S. Ratty, Marcus McWaters, and Leslavska Zerpek. So just wanted to give that disclaimer. I'm not affiliated with any of the authors. I'm not affiliated with Pearson, the publisher. This is entirely a presentation and lecture I created based on the book. So thank you so much for watching, and see you in the next section.